Hi there folks, and welcome to the C++ series with Mike here, and in this lesson we're going to be talking about fundamental data types. Because when we think about programming, what we have to do is take some input data and store it somewhere on the machine. But in C++, what we're going to find is that it is a statically typed language. And that's sort of a fancy way of just saying we're going to pick at compile time, so while our program is running, how much data we want to hold in terms of bytes. And that's going to determine the type of data type that we want, as well as the type of information that we put or store in that particular variable. So let's go ahead and look at primitive data types and learn how to store data. So what I've got here is a table here of the fundamental data types in C++. These are the different types of data types that are built in. Things like integers, longs, which are just bigger integers. And there's even other types like floats, which give us decimal precision, or something that's not familiar or as familiar in, say, the C programming language, bool. But you might recognize again in Java, or if you're coming from Python or these different other languages here. So those are some of the built-in or fundamental data types in C++. In fact, we can find them on CPP reference here under fundamental types. And something also cool about C++ is we can be very specific about how many bits of information that are held. And usually, again, we think about this in terms of bytes. So for instance, an int here, it can be a range of, say, 4 bytes to, well, if we have a bigger type here, like a long, maybe 8 bytes that store the information. And again, the more bytes that we can store, the bigger values. So maybe one way to demonstrate this is just to go ahead and show how to create some of these data types and store them in a variable. So what I'm going to go ahead and do is create a new text file here called types. And I'm just going to set up the main, which is our entry point into the program, and give ourselves a way to write out output here with iostream. So what I want to do here is go ahead and create an integer type here, x here, and assign it some value. So something that's a reasonable integer, like 42 here. And let's just go ahead and print it out, practicing our skill there. And with an end line here, and if we compile and run this program, it should print out 42. That's our expectation here. So let me go ahead and just split these windows here. I'll put the source so that we can see it. And let's compile this with G++, the standard version language we want to use, 17. Not that anything here specifically is a C++ 17 feature. And the program name, which is just called type cpp-o and prog here. And let me just put this all in one line so you can see it there for just a moment here on one single line. And we'll run it and we get 42. So not bad here. But again, what if we try to store something really, really large in this program? Like, I don't know, something like this, if I just hit on my keyboard a few times. Then we try to compile it, and it's going to tell us, hey, we have an overflow in this conversion here. Meaning that, this value here, however big it is, we just don't have enough bytes of information in this particular data type that we're saying x is. And that's typically 4 bytes. Now, how can we check or sort of debug this? Well, first, let's just figure out how big our data type is. And for that, we have a handy operator here. It's called sizeof. And I can either put the type name or the actual variable, and it'll just tell me how many bytes that this data type is. So let's go ahead and just try this out. I need to recompile and resave my changes, rerun my program, and we'll see the number in here, printed out, 4 bytes. And again, 1 byte represents 8 bits of information, so 32 zeros in a row here, ranging to 32 ones all filled in is the amount of data we have. So if I change my data type here to, say, a long, and I again try to store some really big value like this, let's go ahead and try to recompile. This time, no errors, because, well, we have 8 bytes of information here. And again, let's try to change this type here. So a long, which is one of our primitive types down here. And if I just go ahead and scroll over here, we'll see that it's usually at least 64 bits of information. And integers, we know, are at least 16. Usually they're 32 on most systems. And again, this is in bits. So 16 bits here means we have at least 2 bytes. 32 means we have 4 bytes here. Again, just doing those conversions between bits and bytes here. So here I just want to go ahead and just make this an integer, and let's see if we get that warning again, showing us that we don't have enough space here. Okay, so we need a larger data type. Now what happens if you make this number or string even longer? Then you have to, again, maybe make your own custom data type that's not one of the types built in. And we'll talk about how to build your own data types in C++, but for now, we just have the fundamental ones here. Now, something that's introduced in modern C++ that may also be of interest is you can specify the width or how many bits this type is. So let's go ahead and just do an int 64 underscore t, which underscore t is a convention for type here. So this means this integer is filled or can be filled with up to 64 bits of information to represent larger numbers here. So let me go ahead and save after I've made this change here. I'll recompile, and now you'll see that there's no errors here because I'm allowing myself more bits of information to be stored here. And now we can run it and see that full value being printed out. So again, something that might be new in C++ with the primitive types versus if you're coming from JavaScript or say Python is we have to specify the type here. And that's what we call a statically type. So as soon as we compile this program, x is always an integer here that can hold up to 64 bits of information. In other words, storing this number inside of x here. And we have a handy operator here called sizeof, which takes in either the variable name or the type, and it'll return how many bytes of information that can be stored. We'll revisit sizeof and see why exactly this is important to be able to sort of query or figure out how much information we're able to store. And in this lesson, we've also learned about this table here with the primitive types here. And I'll just run through a few more of them just so you can see, again, some of the different types here, and you can, of course, play around with this. So let's say that we have a bool, which could represent a value like true. And let's go ahead and see what happens if we run this program. Then we get a 1, which represents true. It's not going to print out true or anything like that, or a 0 for false, which we should also show here. And again, the size is usually 1 byte on most systems, but it's always nice to query and confirm that. So let me go ahead and recompile this. And now you can just see that false has, again, a value of 0 here. It's not going to print out a string false or anything like that. And some other types that you might want to be aware of, things like floats. So we can store some number like this, 3.14. And often in C++, you'll see a suffix of f to make sure that this is explicitly a floating type here. So let me go ahead and run this here. So you can see 3.14, and this float takes 4 bytes of information. If you need more precision, that is, if we want to extend this, so let's say we have this many digits after the decimal here. Let's go ahead and see if we get any warnings here. Actually, let's add a few more. And let's see here. Well, maybe no warnings, but when we print it out, it's only going to give us the first few digits of precision. We probably want a different type here, and that's called a double, which is double floating point precision, and lets us store bigger integer numbers here. And this is actually being cut off because there's an actual setting for when you're printing out to specify how many digits of precision that you want here. But typically, things default to a double precision unless you make them a float and then explicitly put an f after them for the floating type primitive. Now, what if we want a string in C++? Well, what we can actually do is create a char here, and let's actually just show what one letter is. So let's do something like this, rerun it, and you'll see that we just have the character A, so one single character. Now, strings, of course, are made up of multiple characters, so they could be 0 length, 1 length, or anything greater than that. So what if I try putting in, say, ABC here? And you'll notice between the single quotations, I'm already getting a warning here. It's saying multiple characters. We can try to run it and just see what happens. In this case, it gives us sort of the unpredictable last character. But let's go ahead and see if I try to make this a quotation mark here and have ABC. And let's go ahead and try to rebuild. And this is going to be an error. And it's telling us here that this single character here that we're trying to store, it's actually this const char star thing, which is a little bit weird, but we could say, okay, that's the right type that it's expecting. So let's try const char star here, and we'll go ahead and compile this, run it, and we'll notice ABC, and the size is 8. So there's a little bit of funky stuff going on here with strings here. So we'll have to think a little bit more about what the type is. What I'd recommend for now, before we get into exactly how strings work, is just include from the standard library the type string. And let's go ahead and just put standard string because it's from the standard library here. And compile, run, and we'll see we get ABC. And again, the size of isn't really meaningful because I only really see 3 characters here, maybe 4, because sometimes there's a terminating character. So we'll have to do a little bit of discovery on that. But I just want to make the point that string is not a fundamental type in C++, so that is something to keep straight. That said, you should use strings as often as you want when you want to store information here. And we'll talk about how to optimize strings later with things like string views and so on, but that's just a little teaser. So if you want something that's outside of the language, usually you include it as part of the standard language. Okay, so I think that's enough for this lesson. Let me sort of rewind us here. So we've learned about some of the fundamental types, things like characters, things like floats, things like Boolean values, integers where we can specify the actual width or how many bytes that they have. And this will always have 64 bits, and that's great. So you know it's always 64 bits no matter what system you're using. Again, this is in bits. So 64 bits divided by 8 gives you 8 bytes of information. Okay, then we have other longer types here, like long, if we want to store 8 bytes here. And of course, just integers like this. So I hope this was a useful introduction to various primitive data types that are built into the language. And even though we don't have other types like some languages have, like strings, we do have those as part of the standard library. And of course, we can build our own types, which we're going to learn about in the future. So I hope you're enjoying the series. Now go ahead and take a moment to practice some of the fundamental types on your own that we learned about, print their values off, print their sizes, and then we'll continue on to the next lesson. So make sure you subscribe so you can see it, and we'll see you then.